Hello everyone. So today we are going to solve a problem, get connected components of a graph. So let's see what is the problem, then we will discuss its solution. So we have been given a graph in this form. Here 8 is a uh, number of the elements of a graph, and 5 is number of edges in a graph. So let's see what it says. It is the like traditional input, what will be in most of the cases will be given to us in case of graph. So we are not going to discuss input and output. We are going to discuss the problem, what's the problem, and how we are going to solve it. So we are doing this because there will be some more problems that will be solved using get connected components. So I'm starting with this one. This is our first question graph. So let's see what is it. And one more thing, I'm assuming we already know DFS of a graph, and we also know how to create and initialize the graph. So this is the prerequisite of this question. So if you don't know, you can uh, check on this thing and come back again. So in the question, what we have to do is, we have been given a graph. We need to tell how many connected components are there. So what we mean by connected components is, it in this one all the components are connected, in this one all the components are connected, and this one a separate component. So we need to count how many components are there in our graph. So that's the question. I hope you got it. So let's start. Let's see what we can do. Let me tell you the question again. So we have been given this graph. So this graph corresponds to this. We have been given this input. This input corresponds to this graph, and in this graph we need to find number of components. How many separate components are there? So if these 6, 7 and 8 are already connected to here, 6, 7 and 8, in that case, let's suppose this was not there, and this is all a separate component, and in that case our answer would have been only 1, because there is only one component. So I hope you got what is the connected component. Connected components is like all the elements are connected. So let's see what we will be doing. So for this one we need to reiterate the DFS approach, then only like we can solve this problem. So let's see what is DFS. So what we do in DFS is, first we visit, this is the DFS code, and let's suppose this is our graph, and this is the visual representation, and this is our array, whatever we have stored in our graph. So the first thing we will do is mark it as visited, and second thing, we will loop across all of its edges. So here for 1 we have 2 edges, 2 and 8. So first we will see 2. So 1 is now visited. Now we will move to 2. So 2 is again visited, because the first step in our depth first search is mark it as visited. 2 is visited, and 2's neighbors are 1, 3, 4 and 5. So in this case, what we will be doing is, first we will try to visit one, but we will see one is already visited, so we will not call DFS for one. So we will call for 3, mark it as visited. 3's neighbors is 2, 2 is already visited, we will not go to 2. Then what will happen? 3's call is completed. After this line, 3's call is completed. Then we will again come to 2. 3 is already visited. Now 2's for 2, 1 and 3 are called. Now we will call for 4. So for 4, now we will call from 2. So first thing, 4 will be marked as visited. 4's neighbor is 2, but 2 is already visited, so this condition will not satisfy. We will not go inside this if condition, and again we are not going inside 2. Then again we came back to 2. For 2, 4 is also done. Now we will move to 5. So we will go to 5, mark it as visited. 5 is marked as visited. And now we will check the neighbors of 5. So 5's neighbor is 2, 2 is already visited. This condition will not met, so we will not call DFS. Now 6, for 5 we called 6. So 2 is already visited, no need to check. 6 we called. 6 is visited first. Now what is happening is we will call for neighbors of 6. 6 is 5, 6 neighbor is 5, 5 is already visited, no need to call DFS. Then we will call 7, 7 is visited. 7's neighbor is 8, we will mark it as visited, and 8 will call its neighbors 1 and 7. 1 and 7 are all visited, so we will not do anything. And what is happening in this case is our DFS, if we call for 1, it will eventually go to all the elements of this graph. Like wherever this graph is connected, this DFS will go to all the elements. So similarly, let's suppose if there is another element 9 in this graph, so what will happen? So if there is another element 9 and 10 separate from, not connected to this graph but part of this graph, they will not be visited. So what we can conclude from here is, if we call for any element of a graph and we go to we do DFS, if any element is left, then that is our separate component. So what we can put a logic, we will call DFS for every element and we will check if all are visited, then okay, it's part of that same component only. If anyone is not visited, we can think that it's a separate component, we can increase our count. So this is going to be our logic. So let's see how we are going to approach this thing. So what we are going to do is, we will call DFS. This is the input that has been given to us. So we will call the DFS. So first, for this one, DFS will run and it will cover all of this. So what we get is, we get one component. So we will initialize our count to 0, and whenever we call any component and that is not visited, so what's happening is, after calling our DFS, all of this gets visited. If any component is not visited, we will increase our count. So here our count is 0. So in the first case, when we come to this one, our 1 is not visited. So we will increase our count. We will call the DFS from 1 and it will cover all of this as DFS and mark it as visited. So next time when we call for 2, it's already visited. So we will not even call for DFS or not even increase our count. So it will be till 5, nothing will happen. But when we come to 6, what we see is it's unvisited. So it's unvisited. In that case, we will mark it. Uh, sorry, in that case, it's unvisited. We will increase our count. We will increase our count by 1. So now our count will be 2. We will increase our count and we will call the DFS for 6. And what the DFS for 6 will do, it will mark it as visited and all of its connected component as visited. So for 6 and first, if we call DFS for 6, it will mark 7 as visited and all of its component. Next time when we try to call for 7, it's already visited, so no need to call the DFS. Now we come to 8. 8 is not visited, so we will call DFS for this one and DFS for this one will mark it as visited. And since this was not initially visited, we will increase our count to 3. Now we don't have any element, like our graph is completed, so in that case 3 will be our output. So that is going to be the logic of the problem. So let's see. So I'm assuming we already know how to create a graph, how to initialize, how to populate elements in the graph. So till here I'm not going to explain. This part is just simple DFS. We are marking every element of the graph as visited, and if it is not visited, we are visiting. So this one I already explained. This is the code we need to understand. So first of all, we are making count as 0. So this is our count that will keep track of the components visited. We have initialize visited array with n plus 1 yn plus 1 because in the input the numbers are marked from 1 to n. If it is from 0 to n minus 1, it would have been only n. So now we are checking from 1 to n if any of element is not visited. So that thing I explained. In that case, here if any of element is not visited, so let's suppose at starting 1 is not visited, so definitely 1 is not visited yet. We will call DFS will mark all of its connected component as visited. So for these things, if any element is not visited, then it's it's understandable that it's a new component, like it's a separate component. We have not visited it in the first graph. Like first graph we called and we marked all the connected components as visited, but whenever 6 came, 6 was not visited, so we increased our count for 6 and marked it and call the DFS. So DFS will mark it as visited and all the elements that are connected to it. So here this if it is not visited, then we need to increase the count and we are calling the DFS. So in the end, our count will store all the components of this graph that will be stored in our count. So we need to print. So let me submit it. I just submitted it before to be sure I'm correct. So it ran successfully. Now it's passing all the test cases. So I hope you have understood the approach and problem. So we'll meet in the next video. That will be the implementation that will use connected components. So in next couple of videos we will be using get connected components. So we'll meet in the next video. Till then, goodbye and keep coding.